In this video, the use of the active EMI filter evaluation board is shown. Here is the network analyzer. Next one is the DC supply. And the right one is the PC connected to the network analyzer. The S parameters are displayed on the network analyzer. A signal generator or an EMI receiver spectrum analyzer could be used instead. However, the network analyzer is recommended for its convenience. In this demonstration, port 1 represents the noise source side. Port 2 represents the receiving side. Connect port 1 to the right side of this point. Note that this active EMI filter is unidirectional. If connected the other way, it might not work properly. In this setup, the S1 parameter should be seen. If connected oppositely, the S12 parameter will be seen, because it is unidirectional. There are some 0 ohm resistors here, each connected to one side. In the default setup, all 0 ohm resistors, from RD1 to RD8 are routed. To analyze the noise transfer characteristics of common mode noise, this default setup can be used. To see the noise transfer characteristics of specific lines, keep the 0 ohm resistors on the selected phases, and remove the others. For example, to analyze the noise transfer from the R phase of the noise source side to the T phase of the EMI receiver side, keep RD1 and RD7, and remove the others from RD1 to RD8. There's a 0 ohm resistor at the RD9 point, connected to ground. The bottom port will be used for current mode measurement, demonstrated in the next video. When conducting measurements using the evaluation board, it is crucial to verify the ground connection status. By default, the PCB legs used in the demo board are connected to ground. When measuring parameters like S1, ensure sufficient grounding by placing a ground metal on the floor. This grounding emulates the chassis ground, or earth ground of the actual EUD. Regardless of whether it's a passive or active method, the grounding connection in EMI filters significantly impacts attenuation performance. Once the grounding preparation is complete, connect the DC supply to power up the active EMI filter IC. The DC ground reference of this power supply can float relative to chassis ground without affecting its operation. The plus side should be upside, and downside represents the DC ground in the evaluation board. The DC voltage input can accept up to a maximum of 15 volts. To prevent potential damage from glow discharges, do not connect the power while it is turned on. Connect the power supply after it has been turned off, then turn it on. The display now shows a reduction of S21 from up to 15 dB to a maximum of 23 dB at certain frequency levels. This indicates the noise attenuation performance of the active EMI filter. Noise attenuation can be observed from the baseline level. If the filter is turned off, the noise attenuation characteristics return to the baseline, demonstrating the effectiveness of active cancellation. This is the end of the video. The next video will demonstrate the current gain measurement. Thank you.